Hello, everyone. My name is Andrzej. I'm a Kotlin developer working on Android apps at Bright Inventions. And I've been using Kotlin since 2016 or so. And today I'm gonna tell you how we dealt with this forward-compatible enums serialization in Kotlin, which may sound a bit mystical at first, but you will see that it's quite a common issue nowadays. Okay, so let's get started. First of all, let me remind you that this when expression that we all know is actually not only a when expression. Like, this keyword can be used in two ways.
Sorry, Andrzej, you are not sharing your screen.
Oh, actually, you are right. I'm not. That's correct. Okay, sorry.
Yep, now it works.
That is the first one. Sorry for the trouble. Okay, so anyway, this is where I wanted to talk about this when expressions. And yeah, so when keyword can be used in two ways. First way is this expression, and the other way is a statement. And we say that this when keyword is used as an expression when we want to get some result out of this when, and assign it, for example, to a variable, or I don't know, convert it into a parameter, etc. And statement is the situation where we use when to just invoke some action and we don't get anything out of it. So this former situation with the expression forces the compiler to make sure that for every possible case in when there is something going to be returned out of it. And this is also why we say this when expression is exhaustive. So we need to cover all the possible cases because otherwise the compiler will say that there is something missing here. And these when expressions work the best in with enum classes and sealed classes, where you are forced to implement all the possible cases of enum class or the sealed class, and the IDE is going to help you with that by marking this when expression as incomplete, and you can very easily add the remaining branches there. When you do this, then it gets automatically generated. You can provide some implementation for each branch, and as you can see, the else branch is not required at all because the compiler understands that simply all the cases were already implemented and there is no other case. And interestingly, in Kotlin 1.6, there are also warnings for non-exhaustive when statements, not only expressions. And in 1.7, those warnings will become errors. So Kotlin is actually going in a way that those when both when statements and expressions will need to be reviewed whenever you, for example, add a new enum value to enum class. So I believe this is a good change, and it will prevent us from simply forgetting to handle some new value somewhere in the code base. And in short, we can say those enums and when expressions and statements work really, really well together. Okay, now before we go to the serialization issues, etc., and forward compatibility, I would like you to imagine a simple system that we are working on. And this system processes some kind of orders, let's say. Those orders come from different sources, such as a website or mobile app. Each of those apps can form an order request and send it somewhere. Those order requests are obviously stored, processed, and whatever you want. And we can also assume that each of those apps is developed independently from each other at its own pace. They have their own release cycles, and a dedicated team is working on them. So we can also say these deployments of those apps cannot really be synchronized for various reasons. And we should also remember that in case of mobile applications, it's not obligatory for the mobile app users to install all the updates immediately whenever they are available for them. So this is part of the problem, actually. And okay, let's dig a bit deeper. So we have those order requests, right? And let's imagine that this order request contains some properties, and one of them is the order source property. This order source is something that points to the origin of this order request. So it indicates which application created this order request. And for example, this order source can say that it was created by the website application. Therefore, we can see this JSON on the slide saying website, okay? And of course, in Kotlin code, it can look something like this, where we have the data class with the order request, and we have an enum class for the order source. This makes sense. Of course, you can say that you would do it a bit differently. I understand, okay, but let's assume this is the way, just for this example. Okay, and for now, as you can see, we have 3 different order sources. This partner system X, which sort of indicates some external integration of our system, our website, and perhaps an iOS application. Okay, let's go next. We are going to use this enum value from this order request somewhere in the system. I don't know, maybe on our backend side, maybe on some frontend side, whatever. We are going to use this order source property to choose an icon to be displayed somewhere in the UI perhaps, or maybe an icon to be, I don't know, used for some other purposes. Doesn't matter really. So in this situation, we are in this situation right now, and now let's move to this serialization topic, enum serialization. So first of all, of course, I'm aware there are plenty of ways to serialize some payloads in Kotlin, and well, you know, there are a lot of JSON serialization libraries like JSON, Jackson, Moshi probably, or whatever. And I'm going to use this kotlinx.serialization library today for my examples. And if you are not familiar with this library yet, then I really recommend checking it out. And it's a multi-platform library for Kotlin, so it probably should support this Kotlin, Kotlin native applications that perhaps Piotr is going to talk about next. So anyway, back to our example. When we want to serialize our classes, we need to mark them with this annotation called serializable. And that's pretty much it for now. Then we can use this JSON object, as you can see, to serialize and deserialize some payloads. And yeah, that's pretty obvious for now. Everything is understandable, I hope. And one thing that you may not be familiar with on this slide is this order request serializer line. So just for your information, this is like statically typed serializer generated for us by this library. And we can use this to let the serializing library know which serializer should be used to serialize this particular payload. So, okay, let's go next. So far, so good, by the way. Everything should work here. I checked that myself. And okay, so back to our example. Let's imagine that our system is used in production widely. It's adopted, and we have a significant user base. And we are actually doing so great that we've got some funds to start working on another application we want to add to our system, and this is going to be an Android application this time. So as you might expect, adding this new application to our system is going to require a change in our enum class OrderSource. So we need to add this new value, Android app, to be able to indicate that the new order requests created on it are originated on Android app. And here is the problem. So that enum class should actually be updated in the code base of each application in our system. However, it's not necessarily that easy. And as I previously mentioned, those apps are maintained separately, and they have their own release cycles. Sometimes also the users don't update very frequently. And as a result, we may end up with a situation like this, where the new application we are working on, in this case, this Android application, is obviously has this updated OrderSource enum class, but all the other applications still use the older version of this enum, and they are not aware that we have a new application in our system that can be indicated with this enum. So when we try to deserialize a payload containing this unknown enum value, Android app, then yeah, what's going to happen? Obviously, it's not going to work well, and we won't be able to read that order request at all. So who knows what the consequences of this problem might be, right? Perhaps the application won't even be usable anymore because that order request was, I don't know, a crucial piece of data required to operate properly or something. So this might be a real challenge and a problem. And believe me, I've been there and I've seen that. So fortunately, there are some techniques that can save us from that trouble. And forward compatibility is one of them. It can be described as a design characteristic that allows a system to accept input intended for a later version of itself, according to Wikipedia. And I must admit, it sounds a bit mystically at first. And whenever I read that sentence, I imagine this car in my head and some time travels. But however, in case of our exemplary system, it simply means we should be prepared to accept this future version of the enum, which is this Android app value. And that's it. So nothing really complicated. Okay, in practice, this whole forward compatibility often boils down to first being able to deserialize the payloads without errors, and second, being able to preserve the originally received input that we don't really support and we don't understand. And at this point, it's important to remember that replacing the value we received with some kind of fallback value is often not enough, because we are losing the original value this way. And I've seen some blog posts around the internet from people who suggested this kind of solutions. So I hope they are not caching this data that they receive and replace with something else, because, well, this is not going to work well for them. Okay, so what else can be done? The simplest solution to this problem is replacing the enum type in our order request class with a string. And it might be good enough sometimes, but the lack of enum makes it much harder to understand the code at first glance. it's not obvious anymore what kind of strings we expect here. So this is not really very well. The next problem is that whenever we want to use this property, we first need to find the matching enum value manually, like here. And unfortunately, this can throw an exception because when we can't find the matching enum, then of course we need to catch this exception and handle this in the catch block probably. So this is also not a perfect solution. It both is hardly readable, and we don't cover all the cases with our when expression anymore, because part of the implementation is in the when and part of this implementation is in the catch block. Okay, so to quickly summarize, it still has some pros, right? This is a very simple solution. It allows us to preserve the originally received value, of course. But on the other hand, the readability is really not the best. And the when expression doesn't cover all the cases anymore. So before you know it, you will end up with strings and try-catch blocks literally everywhere in your code base. However, I've got good news for you because when we spotted this problem in Bright Inventions, we came up with a very simple solution we called codified. This is a very small and simple library that will help you with this forward-compatible enum serialization. It allows you to explicitly mark the places in the code where you expect the unexpected enum values. And it reinforces the when expressions by allowing you to get rid of all the try-catch blocks. So let me show you how it works. Okay. In Codified, you can find a sealed class called codified enum. And this class wraps either a supported or a known enum value or this unknown value by using a row type such as string in this place. And when you have this codified enum variable somewhere in your code, like here, it doesn't matter where we got it from for now, for this example. You can use this when statement or when expression to check whether this codified enum holds a value that is known to us or unknown. Okay, and going back to this previous example where we had this try-catch block to prevent our app from crashing when there is no matching enum value for the string received, you can see that this approach is much easier and much clearer, easier to understand, easier to read. We can check the wrapped value very easily in both cases. So when this known enum is passed to us, we can access it really easily and use another when statement or expression to cover all the cases again. And in case of an unknown value, we can simply access this row type that we received, such as string, right? Okay. And okay, next. So here you can see a few additional useful functions that can make your life even easier with Codified. So you can very easily convert both the enum value and the row type into this codified enum instance. This can be seen here and here. In the first example, we have an enum, and using this extension function, we can convert it to codified enum. In the second example, we have a string, and using this extension function again, we can convert this string into an unknown codified enum. Yeah. And then when we have this codified enum, we can also access very easily the code of this enum, regardless of whether it was known or unknown before. And we can also use a function called known or null. So we are going to end up with either a non-enum value or with a null. So this is a very common case, according to my experience at least. Okay, so this last function that I said about, this non or null, is very useful if we simply want to ignore these values that we don't know and we are not aware of them. Like in this example, where we simply don't want to load any kind of icon in our system if the enum was unknown. Okay, and going back to this serialization issue, so this is what we need to do in order to use codified in our OrderSource enum. And first of all, we need to implement this interface called codified by specifying the row type used to encode the enum, and we choose how it should actually be done. So in this particular case, you can see that we by default use the name of the enum, but just for the purpose of this presentation and this example, I'm showing you that you can also override this code in any enum you wish with an arbitrary value, like just some other kind of string, not necessarily the name of the enum. Okay, and the next step is creating a custom serializer for this codified enum type holding our enum class. Okay, so this is pretty easy, I hope. And there is also, you can see here that there is another utility function in codified library that allows you to generate this serializer very easily. So basically all you need to do is to specify the types here, and that's pretty simple. And next, going back to our OrderSource data class, we need to replace the original enum type in this OrderSource property with this codified enum. And we need to apply a custom serializer using this annotation. And this is, of course, only relevant for this kotlinx.serialization library, but I suppose that using other libraries, we could do it a bit differently. Anyway, this is how I often do it in my code. And as you can see, we are specifying this in the annotation, the serializer we wrote before. And of course, as I said before, we replace the enum with codified enum. Okay. And next, this is actually everything we have to do. So as you can see, now we can decode a string containing an unknown enum. And when I printed it, just to show you the result, then this is of course going to be understood as an unknown codified enum value holding this Android app string, which is like this raw value we provided in JSON payload. So I hope this solves problems, at least some of you guys. And okay, so just to quickly summarize this whole presentation, again, this when expressions, when statements are really great with enums. They are making our lives much easier. They are, preventing us from making simple, stupid errors and forgetting to handle some values, new values of enum classes whenever we add some. And this need for forward compatibility is quite common, especially when we use those enums, because of course it's, I think, inevitable to modify them from time to time and add some new value there. And fortunately, we don't have to sacrifice one for another. So we don't have to sacrifice the usage of enums with when expressions, when statements for forward compatibility. Remember to check this link of this library. Feel free to contribute. In my opinion, it should be possible to add support for other serialization libraries other than kotlinx.serialization. So if you wish to contribute, you have some power and resources, then feel welcomed. Okay. And that's pretty much it. I hope you enjoyed this and hope you learned something new. That's pretty much it. If you have some questions, then feel free to ask. And thank you.
Awesome. Thanks, Andrzej. Yeah, so in my opinion, this library is greatly under promoted. So like go there, just check it out. And it's also a good opportunity to maybe promote it as a preferred sort of promoted way in Kotlin ecosystem to handle this kind of problem, because as far as I know, Kotlin doesn't propose an official way, right, to handle this stuff.
Yes, unfortunately.
So, yeah, so maybe it would be nice to bring it to some Kotlin folks. Maybe, yeah, this is some great approach actually. Okay, thanks a lot. As Andrzej said, feel free to ask questions on Slido under Kotlin ID.